Okay, so it all starts with this. It all starts with taking the radius of a circle, peeling it off its normal spot, and then laying it on the circle. That angle that marks off one radius length. So this is one radius length lying on the circle, so that angle is how many radians? 1 radian, because the rays are marking off one radius length. And radians measure openness, right? Openness. Radius lengths measure arc length, but the number is the same. So radians measure openness. Radius lengths, or radii, is what we talk about in terms of length around the circle, but the number is the same. That's where radians comes from. So it's two different quantities. One quantity is length. The other quantity is openness. But that's how we get the amount of openness, from that number of arc length, radius lengths on the arc. Okay. So here's 1.5 radius lengths. It makes it almost to the top of the circle. 1.5 radius lengths. What's the openness in radians? What's the openness in radians? You all should be saying it. 1.5. 1.5 radius lengths, then, is that openness of the rays 1.5. Here's 2.6. 2.6 radius lengths means an openness of 2.6 radians. Whoa, come back. Wow. There's 3. There's 3. This is the example we did last time. 3 radius lengths, openness of 3 radians. So then we can keep going around the circle, and every time there's a tick there, it's a whole number of radius lengths. So 1, 2, 3, 4, 5, 6. All the way around the circle is something like 6.25. Something like 6.25 radius lengths. Okay, so let's go back to what would be really nice is, so notice that the whole number of radius lengths don't fall in nice symmetric places on the circle. They're just kind of haphazard random places. Not very useful. Useful for understanding what we're doing, right? And because they make for nice easy numbers, 1, 2, 3, 4, 5. But what would be nice is if we knew how far it was halfway around. So here's 3.09, and then here's 3.19. So exactly halfway around the circle is something between 3.09 and 3.19. So some of you already know what familiar number is between 3.09 and 3.19. So you want to try what? You said 3.14. So I'm going to let n equal, that's my angle measure, 3.14. Okay, that looks close, but let's zoom in. And see how we did with 3.14. Halfway between 3.09 and 3.19. So here's the terminal side of the ray, this one right here. Terminal ray is there. And then this is the x-axis, which represents halfway around. More or less than 3.14 to get halfway around. We need a little bit more. We need a little bit more than 3.14. So what should it be? 3.14, 1 to 159. So at this view, that looks really, really close. So we could keep zooming in, and this is very, very close. And you know that this number is, so this is a meaning for pi, right? So pi, or about 3.1416, is what? Can you explain what that number is? Tell the person next to you. Pi is, so 3.1416, number of what? What is that number? What does it mean? Go. There should be 40 people talking right now. So what is it? What is 3.1416? Odie. Doing something else. How about Cole? Did you get it?
It's the amount of radians it takes to go halfway around the circle.
Okay, so it's a radians and openness to go halfway around the circle. And another thing we could say is also it is the. What about halfway? So yeah, so it's the number of he said the number of radians of openness for halfway around the circle, which is the same as what? Who has learned something in the last 2 days? The number of radius lengths. The number of radius lengths to get you exactly halfway around the circle if you were laying them on the circle. And why? Because that's where the number of radians of openness comes from. It comes from the number of radius lengths. Sound like a broken. I'm probably putting you to sleep by saying it so many times that you're not getting it. The number of. I'm trying. To get halfway around the circle. Three doesn't make it quite all the way halfway around. So it's going to be three and some change, right? How much change? 0.14159 da 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 da. What the number that makes pi, right? 3.14156 whatever. Here's 3 radius lengths to get. So 3 and a little bit more, such that it's 3.14159 radius lengths to get halfway around the circle. So then what about a full circle? Two of those, right? 2 pi. Okay, so here's 1 radius length of arc length, 2 radius lengths, 3 radius lengths. Halfway around the circle, how many radius lengths? Pi. 4 radius lengths, 5, 6 radius lengths, all the way around the circle exactly, which is about 6.28. 6.28 is not exact. 2 pi is exact. So 6.28 is just a close approximation, just like 3.14 is a close approximation. But to get it exactly, you need all the decimal places to infinity. An infinite number of decimal places. And that's why we use the symbol pi. Because it's going to take too long to write all those out. Like we can never do it. Okay? So what about 1/4 of a circle? Pi over 2. So now, pi over 2 is not a label for the top of the circle. So this is students who have had trig before. You may have come to think about pi over 2 as, oh, that's just that spot at the top. No, it's a number of radius lengths. If this is 1 radius length and this is 2, then what's pi over 2? How many, about, just very quick estimate, how many radius lengths? Between 1 and 2, it's a little closer to 2. About 1.6. See that? just happened? No idea what just happened. There we go. Okay, so this number is about 1.6. Okay, so at the bottom of the circle, how many exactly at the bottom? If this is pi to halfway? Yeah, so like 1.5 pi, right? 1.5 pi to the bottom. Quick estimate. What is 1.5 pi? Quick estimate. How many radius lengths or how many radians? 4.7. Right? 4.7. It's between 4 and 5, closer to 5. Find that value in your calculator. Find 1.5 pi. We're expecting it to be close to 4.7. 4.712. So 1.5 pi or 3 pi over 2 is still a number of radius lengths to get to that place on the circle. It's not just a label marking the bottom of the circle. It's a number of radians or a number of radius lengths to get there. Okay, so between 4 and 5, closer to 4. 4.712 to be exact. Okay, so we talked about, it's all about percent of the circle, right? Fraction of the circle. Our home base for measuring angles is fraction of the circle. Remember we did the pizza cutter and it was a 1/9 angle, 1/9. So then I want to know what fraction of the circle is 1 radian? So this is 1 radian of openness. What fraction of the circle is that? You got it? He wants 1 over 2 pi. Is that right? Okay, let's find that. So 1 over 2 pi is 0. Is it 1.5 or 159 something? 155? Is that right? Did I remember that correctly? Okay. So 1 radian is like 15.9% of the circle. So I want you to use that fact to easily find how many degrees is 1 radian. How many degrees is 1 radian? Now we know that 1 radian is 0.159155 of a circle, or 15.9% of a circle. So how many degrees is 1 radian? How many degrees is that? What would you do? So how can I use the fact that I've got this fraction of a circle to find how many degrees that is? Yeah, Brian? Yeah, is that what you're going to say? Yeah, so we're going to take that fraction now of 360. That fraction of 360 will give me the degrees. So 0.159 of 360. And is that 57 or something? Was it? 57.24 degrees. So in terms of converting between one unit of angle measure to another, we're not going to memorize any formulas. We're just going to always do it based on fraction of the circle or percent of the circle. We said that was our basis for measuring angles, so let's use it. Okay, if you've got 1 radian, find what fraction of the circle it is. Then take that fraction of 360, and that'll be how many degrees it is. Really, really nice way of thinking about it. So let's do some practice. So let's just do, how about, oh, I understand what happened. Where is that? Oh, I know what happened. Okay, so here's 170 degrees. 170 degrees, I want you to find out how many radians is that, okay? No formulas, just think it through like by fraction of the circle. 170 degrees. So is that more or less than halfway around the circle? 170. A little bit less. So where do we go first? So from degrees, we're going to go to what? We're going to go to percent of the circle. What percent of the circle is 170 degrees? So 170 degrees, we're going to find out what percent of the circle is this by doing the calculation. 170 over 360. That's going to be the fraction of a whole circle we got. And you said that is? 47.22%. Now if I want radians, I'm going to take 47.22% of what? Of 2 pi, of whatever a full circle in radians is. So we want that fraction or that percent of a full circle in radians. So it's going to be 0.4722 times 2 pi. Which should be something close to, so if we were just going to guess, something close to what? 3, right? We know 3 radians is just shy of halfway around. And what do you get? How many radians is it? 2.967 radians. Which makes sense because it's close to 3. Okay, gradients. There are 400 gradients in a circle. So I want you to tell me how many degrees and radians is 382 gradients. So this is 382 gradients. This is this amount of openness right there is 382 gradients. So how many degrees is that equivalent to in openness, and how many radians of openness is that? So what do you want to start with? Nope, I'm not going to start with degrees. Fraction or percent of the circle. Fraction or percent of the circle, and then it's easy from there. What fraction or percent of the circle is 382 gradients? Tell me again. 95.5%. So then to get degrees, what will I do? I want that percent of 360. And then to get radians, what will I do? I'm hearing some people say subtract. Take that fraction or that percent of 2 pi. All of these angles, it's the same angle, so in every case it's 0.955 or 95.5%. So we take 0.955 of 360 to get degrees, take 0.955 of 2 pi to get radians. So go to your home base first, percent of the circle, and then all you need to know is what a full circle is for whatever unit you're dealing with, you take that percent or fraction.